Hello everyone, bonjour tout le monde, thank you for coming. Today I'll talk about a question, what do you prefer? Please raise your hand. Do you prefer unusable or undebuggable? Unusable, raise your hand. Okay, a few people. And undebuggable? Interesting. Okay. So first, shortly, who I am. I've been developing for Android since 2014. I've been using smartwatches since 2015. And I still am, but usually I have only one. It's just because it's Android makers. Times droidcon, of course. I've loved Kotlin since 2016, and I do open source software, especially with one project that I named Splitis since 2016, and also a few other projects. Maybe some of you know refresh versions, which is also something I'm contributing to. These days, I'm focused on ChartsKT, which is a Kotlin multi-platform library for charting that works on Android, iOS, the JVM, the browser as well. And also doing a bit of Wear OS, which is how I went on to giving this talk today. First, before talking about the unusable and undebuggable, I want to talk about a basic feature in LazyColumn, item animations. Who wants item animations in LazyColumn? A bunch of hands. Apparently, a lot of other people, 540 people, found this on the issue tracker or somewhere on the internet and said +1. And so you can see it's still a sign, it's not resolved yet. And what we can see here, apart that a bunch of people apparently want it, is that it's been updated recently. That screenshot is from yesterday. So it's been updated about a month ago. And they say that addition, removals, animation is still in progress. So in progress, but not in your app, in progress of still not being there. It's been 3 years that, at least 3 years that people have been waiting for that into LazyColumn for Compose. While RecycleView has it out of the box, you can have animation when something comes in, and that when the data set is not super large, it's very handy for the user to notice that something happened. And so, who is lazy here? Now, I want to talk about scaling LazyColumn, which is based on LazyColumn, which is something made for Wear OS watches. And this is what last year was apparently the best smartwatch that you could get, the Samsung Galaxy Watch 4, which was the first one to get Wear OS 3. And here is how the latest and greatest look like in debug mode. It's a cold launch for your information. Silk smooth. Rendering at 60 frames per second. You see my finger moving. So I opened an issue when I saw that there was a bunch of junk in there. And I also have been able to reproduce it on 3 watches. This one is not compatible, unfortunately. But it's unreproducible on the emulator. And that, for the ones that were understanding French and were the tools from PY, Pierre-Yves, about performance and Android, you know, the emulator, don't trust it for the performance. So I reported it last year, about 2 years ago, and it was closed as completed within 4 days. Much better than 3 months, right? There's been a pull request that was merged very quickly, and basically it was enabling to release builds without having to set up the key store, so that it would be a lot easier to try that official sample in release mode. But that was not really handling the core issue that you cannot have a debuggable build that is smooth out of the box. So, conclusion. Don't debug your app on an actual watch. Enjoy the ergonomics of manipulating a watch emulator with a mouse pointer or a trackpad or whatever. So you get a sense of what the user will never feel, right? Okay, I hope you get the irony. Or you can go with a release build, but is it really slower than debug builds? Yes, especially like you already pay a bunch of time for installation, depending on the watch. Some are quite fast, but release build, you know, I think it's usually slower than the debugger build. So you have two option sets. Either it's unusable or undebuggable, or it's kind of usable and debuggable. Or you can have a third option, which is hack around. We don't know what the result will be, but this is the option that I picked. So not exactly like this, but here's how it happened in my mind. I was thinking, but back in 2015, when I had my first Wear watch, I think scrolling was fairly smooth, so why now on the latest watch, on the latest operating system with the latest tools, should it be that laggy? I mean, I was running a debug mode. Of course, it would take a bit of time to launch, but then scrolling was smooth. I don't remember Recycler View being laggy. But also thinking about Recycler View, people say that it's verbose, but I don't think it has to be. People need to know. You don't necessarily need to write yet another adapter and subclass and override this method again and again. There are some ways to do it just once. I think there was one library named LazyAdapter. There are many ways to do it, but if you want to do what LazyColumn does, you can do it just once for Recycler View and reuse it after. And talking about lagging behind, it seems like deja vu, because for insertion and removal animations, also I was missing that feature, and when I wanted it, what I did is using a Recycler View inside Compose to then have Compose inside the Recycler View. So maybe I can reuse that. Let's try that again. So I was ready to hack around. But first, let's take a step back and just talk a bit about LazyColumn versus Recycler View, which were two things in my mind. So with LazyColumn, you have a simple and high-level API out of the box. It looks very easy, and it is easy. While on Recycler View, the API is a bit lower level, and by default, it seems complex. That's what you see when you look at the docs. But with LazyColumn, you don't have insertion and removal animations, only reordering if you don't change the actual content, only the order, which is kind of an edge case in my opinion. While Recycler View animates all item changes by default. So talking about usability, it seems that it's leaning more towards Recycler View for now. The performance is okay, but sometimes also poor in debug mode. I also noticed it's very subtle, but I noticed it on the phones, and it was way more obvious on the watches, which are, of course, less powered because of battery constraints and sometimes also CPUs. While on the Recycler View, it's as smooth as the content. Like a Recycler View is not really making your app slower if you use it. Also, I noticed that on the Samsung Galaxy Watch 4 with LazyColumn, there's some friction, a higher friction on LazyColumn that you will have on non-LazyColumn or scaling LazyColumn dependent lists. So, like I feel that I cannot scroll as fast with the LazyColumn, even in release mode, compared to Recycler View. Somehow I haven't felt that the same on other watches. But yeah, that was my experience. While the Recycler View seems to keep all user input if I scroll fast, and even if sometimes it struggles a bit because there's a lot of content, a lot of views to generate, it still goes where I wanted it to be. It keeps the inertia. But what if LazyColumn were using Recycler View under the hood? For those of you that are doing iOS development, I guess you know about SwiftUI. Who knows about SwiftUI here and is using it? Okay, less people, but still. So I heard that, I haven't checked, but I heard yesterday that SwiftUI cannot does that on iOS, where they are using UI table view, which is from UIKit, to power the lazy vertical stack and lazy horizontal stack, which is analog for LazyColumn and LazyRow in Compose. So maybe that's not such a bad idea after all. And what if we try to make that chimera, where we will keep the simple high-level API, but have all the other features that the Recycler View provides to us? So what is the most interesting here, the new thing, is having that simple API on top of Recycler View. And for that, we'll switch to some code, because I wrote that code a while ago, and I'm still using it. So here we are, let me find the mouse pointer, okay. Here we are on a composable function where I'm using LazyColumn with recycler view. You can see that I can just use LazyColumn instead, and then bring the import. I think it's this one. You see, it's almost the same API, just the name of the function is changing, and one import when it's the LazyColumn one. So how is it working? Actually, I haven't started by implementing that one, but I implemented a simpler version. You see that this one has a specific scope where you can use the items, but also the item lambda, where you can have multiple types of items. But before, I just tried with a single type. So it's a bit above here. And so I would just pass a list of items, a key, if there was any. Well, I think it was required in that case, and the item content. And so I would need to remember the recycler view adapter, which I created with this handy function that basically brings me a compose view as a view item, and then I call the set content there, so that I can still use compose inside, and I don't need to mind much about the fact that it's using recycler view. And there I have the Android view that contains my recycler view, which is actually inflated through XML here. It doesn't want to go, or I think it's in another project. Here it is. So it's just a recycler view with a style that brings the scroll bars, because you cannot do it without XML. Okay, so here I create the recycler view. I set the adapter, if it's been updated, and the layout manager, which is inside that custom adapter that we have before. And then I need to look for changes into the items parameter. So here I'm using launch effect, and whenever it changes, or for the first value, for the first composition, it will submit the list and await for it to be committed. Even though awaiting for it is not really necessary in that case because there's no concurrency. But yeah, you got the idea. But that didn't look exactly like LazyColumn, and that made it a bit harder for me to switch between the two and do some comparisons. So I wanted to have the one where I would have the items thing here. And that proved a bit tricky, because when you look at LazyColumn, let me write one here. You see that it takes a LazyColumn scope, but that LazyColumn scope here, sorry, the lazy list scope, that content here, it's not a composable function. But it seems it still kind of is, because when you are referencing a state here, and that state changes, you actually get the change reflected into the LazyColumn. But with normal lambdas, you cannot have that usually. And so to have that working, I had to hack. Not a lot, but I think that's actually how it's happening in the core LazyColumn. So what I needed is to run that lambda that will read the state, and therefore will subscribe to any changes to that state, any state that would have been read. I needed to run it inside the composable body, so that it would be recomposed if there are any changes. So this, you can see it's neatly commented here about the why. And so that function, it takes the content, it runs it, but it also checks whether it's sealed, because the recycler view is a bit less flexible than LazyColumn, and so there are some cases where you will not know which adapter it belongs to. So yeah, again, documented. And then I also needed to take into account the content padding, which is, content padding, it's a parameter that you have in LazyColumn, and I want it to be really a drop-in replacement, so I could keep trying. So I had to translate that to paddings, so then I could use that padding into the recycler view itself. And then there was yet another trickery, especially specific to Wear OS. It's the rotary input. You know, on the Pixel Watch, for example, you have a digital crown that you can turn, and it's supposed to scroll the recycle view very precisely, and it's really helpful if you are moving but you want to keep scrolling something precisely, rather than on a tiny touchscreen, and also you don't have your finger in front, so it's pretty cool. But the problem is that Compose takes full ownership of the focus and doesn't bring it back to views. And the way those rotary events from the digital crown are brought to the view, they also interact with the focus, and so if you don't have the focus, you don't have it. And the view inside the Compose doesn't have it, so I had to do something to bypass Compose when I would see that there's not a Compose but a view that is actually focused, so that it will still be natural. So I kind of had to do what Compose was not doing for me. And you can see that by default I ask it to request focus, which can also, but not always, can sometimes be handy for accessibility if you only have list content, but can also be a nightmare if you have something after that list. So you need to, it might not be the best idea in all cases, but in the case of Wear OS app, it was very handy. And so this is working with what I call a generic motion event dispatcher, where I call this from an activity. So I made a base activity based on component activity, and here I try to put it into a generic motion event dispatcher, and that generic motion event dispatcher will keep any views that are focused. So usually there should be only one or none, and then it will forward that to the view using the dispatch generic motion event to the target view, but only if you have a focus view. And so that's where I need to call this function, the put view until cancelled. I call that within the scope of my LazyColumn with recycle view here. And so while it's around, then I want to keep the view inside. And if I back out, the composition will lead to cancelling the scope, and that will get removed, and it will go back to whatever Compose code we wanted to handle focus. Okay, I think I showed most of it. All the code is online. I will show you the link just after. Just be sure to search for this LazyColumn with recycler view, because it's inside a repo that has a bunch of things, and you don't want to get lost. So if you want to look a bit more how the adapter is actually implemented, which probably will be very familiar if you ever use it, you can look at it. So yeah, there we go. But I had to put an asterisk, unfortunately, to the as smooth as its content. So why was it slow for Compose? The thing is that Compose is very, very unbundled from the system, and the classes from the system, especially in the view system, are pre-optimized, but it's not the case for the Compose runtime. But there are some facility inside Android to improve it, and you can have it especially in release mode. But basically, you need to use the app a bit to show the system which what parts in the code are the hotspots, and it will try to make that part more optimized and run faster. It will compile it to something lower level, let's say, let's put it that way. So here we are using a bit more of the view system, so it improves the performance a bit, but unfortunately, when you just start the app, it still has not such a great frame rate, but at least it doesn't discard the input event. So if you scroll and it's laggy, it will still get to how it will still register the fling, which is not the case with the scaling LazyColumn to date, at least. So that's still an improvement for me, and that helps me to navigate with the muscle memory into my app while I'm debugging it. And then when I'm ready, I'm confident I have very little bugs, very few bugs. Then I switch to the reusable, to the release compiled mode. So yeah, better than nothing, but promise only half kept in a way. That's how it is at times. But we got item animations, and I'm really happy to have that. So the code is here in the splitties repository. If you look for my name on GitHub, you will find it. It's pinned. And a bonus offer, if you want to try my bicycle, I bought it to Paris. The same bike that I rode from Lille to Amsterdam recently to just go to a conference. I will give, you can start by walking it, so it's a bit safe. It's quite safe, actually. I will give such instruction in French or in English, no problem. I think it's fun. That's my opinion. I'm biased, of course, and you can find me if you want to try it. It's just parked in front of the venue. It's called a recommend bicycle. More comfortable, a bit faster, less air drag. Yeah, that's just that thing. So yeah, you can find the slides there. If you want, you can take the QR code. It's on Speaker Deck. I think you can also find it by searching my name. There are only 2 decks on Speaker Deck so far. Thank you.